Good day viewers, you are welcome to today's math class. Today we'll be talking about the laws of logarithm. So I want you to know that the log of n number with the base a, written as this, right, is equal to how many times a is raised, or the numbers of power a is raised in order to obtain n. So now what I mean is that I said let log n base a to be equal to x, right? So n, which is the log number, is equal to the amount of times in which a is raised. So a is raised to the power of x and x is unknown because that's the amount of times a is raised. So this is equal to this, and this is an initial expression of this log form, right? So now looking at the laws of logarithm, starting with the additional rule. So we have the additional rule which states that when you have log x base a plus log y base a, right, this is definitely equals to log x multiplied by y with the base a. So this is the first property we are looking at. So let's solve an example on this. When you have log 4 base 10 plus log 25 base 10, right, this is equals to, using this property, is going to be log 4 multiplied by 25 into brackets base 10. So 4 multiplied by 25, that's 100, right? So we have log 100 base 10. Now we can solve this in two ways. We can solve it using this property here I listed above, or we should equate the number and the base. But let's use this property here now. So when you use this property here now, we can say that let this to be equals to x, right? And when this is equals to x, we are going to have 100 is equals to 10 raised to the power of x. So equate the base. So we have 10 raised to the power of 2, which is 100, right? Is equals to 10 raised to the power of s. Dividing. So since the base are equal, the power also will be equal. So we have x equals to 2. Now let's look at the second property, which is that of subtraction. So the subtraction law, when you have log x base a minus log y base a, this is equals to log x divided by y, right, base a. So now these two are same. Now let's solve this question. Look at it. When you have log, an example, right, log 28 base 4 minus log 14 base 4. Using this property, we are going to have log 28 divided by 14 into bracket base 4. So 28 divided by 14 is 2, right? So you have log 2 divided by 4. Now using these laws, we are going to have log 2 base 4 is equals to x, right? So we have 2 is equals to 4 raised to the power of s. Now let's equate the denominator. Let's equate the base. So we have 2 is equals to 2 raised to the power of 2x. Now since the base are equal, we are going to be left with, this is raised to the power of 1, right? So equating the power, we have 1 is equals to 2x. Dividing both sides by 2, we have x to be equals to 1 over 2. Now let's move to another rule. So the next one is the power law. Now under this power law, when you have log x raised to the power of n with the base a, this is equal to n log x base a, right? So let's solve an example on this. When you have log 2 raised to the power of log 8 raised to the power of 3 with the base 2, right? So using this property, we are going to have 3 log 8 base 2, right? So now You know that when we have something like this, we used to solve it in this form. Let me to teach you other form in which you can solve question like this. And the other, so now equating the number and the base. So we have 3 is equals to 8 is, we can write it as 2 raised to the power of 3 with the base 2, right? So now using this property again, we are going to be having 3 multiplied by 3 log 2 with the base 2, right? So now when the log number and the base is the same, it is going to definitely cancel out each other, right? So we have 3 multiplied by 3, which is 9. In case you don't know, you are knowing it now. So we are through with the power law. Let's move to another law. Which next on the list is the power base. So when the base is raised to a power, for instance now when you have log x and the base, which is a, is raised to the power of b, this is equals to 1 over b multiplied by log s base a. Now let's look at this question. Example, when you have log 16 with the base 2 raised to the power of 3, right? How do you solve this kind of question? Using this property, we know that we are going to have 1 over 3 log 16 with the base 2. Now, next thing to do is to equate the number at the base, right? The way we did this. So we have 1 over 3 log, yeah, we have 4, we can write 16 as 2 raised to the power of 4, right? And we have the base 2. So if you look at this carefully, we are going to be using this power law by bringing this 4 to this side. And when we do so, we are going to have 4 over 3 log 2 with the base 2, right? So this cancel out each other is going to give us 1. This is going to give us 1. Therefore, 1 times 4 over 3 is equal to 4 over 3. So we are through with this. Let's look at another property. So under this property, we have the reciprocal law. Here, when you have log x with the base a, this is equals to 1 over log a base x. So what does that mean? Let's look at this question. For instance, example, when you have log 8 with the base 4, this is equals to, using this property, is going to give us 1 over log 4 base 8, right? So how do you solve this kind of question? So we can equate the number and the base together, right? So when we have log, for the number we have 2 raised to the power of 2, and for the base we are going to have 2 raised to the power of 3. Now using the property of power base, here we have 1 over 3, right? And using the property of power law, we are going to have multiplied by 2, and we are going to be left with log 2 base 2, right? So here now this cancel out, this is going to give us 1. 1 multiplied by 2 over 3 is 2 over 3. So 2 over 3 is our answer here. And also another property to recall is change of base. Now on this property, when you have log x divided by log a, this is equals to log x base n divided by log a base n. So how do we solve this kind of question? Example, looking at this property, when you have looking at this question rather, log 8 base 3, this is equals to, don't forget, log, the natural form of a log is in base 10, right? So we have log 8 base 10 divided by log 3 base 10. And when you punch this to your calculator, because you can simplify this, we are going to have 0.9031 in the numerator, and denominator is 0.4771. And when you divide both sides, the value is 1893, approximately 1893. Now I want you to know this: when you have log of 1 with any base, whether base 10, base 4, any base, this is equals to 0. Just know this. So this is one of the property. You can try it yourself. And also another property to recall is, for instance, you have log b with the base a, and this is also raised to the power of a. This is equals to b. This is another property to recall. For instance, you have 4 raised to the power of log 2 with the base 4, right? This is equals to 2. So know this. And we are through with laws of logarithm. Guys, please don't forget to like, share and subscribe to my channel. Thank you.